Okay, so the question reads, the equation of a plane progressive wave is given by the equation, the one that we have there on the board, where y and x are in centimeters and t is in seconds. Calculate the amplitude, frequency, wavelength, and velocity of the wave. So to start with, this is what we need to know. The general wave will be given by the following formula. Different from the previous one. For this one, we're saying y. So the general equation of a wave in motion is given by, okay, so we have y is equals to a sine, is 2 pi, yes, 2 pi over lambda, 2 pi over lambda, open brackets dt minus x. This is the general formula for a wave in motion. So our job is just to compare what we have in the two equations. What we've been given is this one, so we just compare what we have. Amplitude, so we have sine, before the sine we have 10, here we have 8, so amplitude in this case is simply equals to 5, so I'm 10 meters. We're done. Now, how about the wavelength? So this is what I want to do. Here we only need x, but here remember we have 0.005. So let's get this guy and say y is equals to 10 sine 2 pi t minus, so let's change from a decimal, let's have it as a fraction. The fraction will be 5 over 1000. 5 over 1000 is the same as 0.005. Is it over 1000 or over 200? Are you sure? It's over 1000, eh? Okay, let's reduce it now. So y is equals to 10 sine 2 pi t minus, so 5 goes into 5 once, 5 goes into 1200 times, and we have x. That. So remember, we only want x. So how do we get rid of the 200? We need to factor it out. This is how we're going to factor it out. We're going to say y is equals to 10 sine 2 pi. If we factor out the 200, it comes here. But remember, you cannot factor out what is not common. We don't have the 200 here. So what we do, we shall say 200t minus x. Here's the thing. If you multiply this and this, the 200 will cancel, giving you only t. If you multiply the 200 times that x, then you have the 200 there. So that's why we're putting the 200 here. Factor it out, but this guy will have the 200. So that's the same thing. So now, what do we want? Remember, this is coming from our equation, this one. So we're saying whatever we have here, we compare these two so that we can find the value of lambda. So to find lambda, we shall say 2 pi over lambda, this part, is equals to 2 pi over 200. So it's obvious that lambda is what? 200. So lambda is, oh, by the way, I think it was measured in centimeters, right? We're told that it's in centimeters. So in meters, we can convert it. We can just say A is 0.1 meters. Then lambda here, it's obvious that lambda is 200 centimeters, meaning that lambda is 2 meters. But since it is measured in centimeters, we can also use centimeters as they are. What else are they asking for? Frequency. How do we find the frequency? Any idea? So we'll come to the frequency. First of all, let's look at the velocity. Remember, in our general formula, we have a v here. In the general formula, we have a v. In this formula that we have here, we're not using this one. We're using this one that we factored out to 200. We have 200 here. So the coefficient of t here is 200. The coefficient of t here is v. So it's obvious that V is equals to what? 200 centimeters, meaning that V is equals to 2 meters. Like that. Is that okay? Then, how do we find frequency? Using the formula for speed. We know that frequency, or rather speed, is equals to lambda times frequency. So, speed is equals to, what's the wavelength? We'll use 2. No. Let's make frequency the subject of the formula. So frequency will be equals to velocity over the wavelength. So what's the speed? 2 meters. What's the wavelength? 2 meters. Hence, the frequency is simply 1 per second. So if you've been asked to find period will be 1 over frequency, which is 1 over 1, which is just 1 second. So that's it.